So, good afternoon, everybody. Thanks for this patience in continuing here. And I'm talking a little bit from my current approach with physical and digital connection. That's part of my PhD. So I'm doing some experiments with 3D printing. And in order to push students in that creative way, but also trying to observe these learning opportunities in that kind of approach. So basically, I'm talking a bit about that and sharing some ideas and perspectives in doing that. So first of all, I have to explain a little bit about my initial, or the first part of my research. Actually, my research started in 2016, and I was doing some experiments with future teachers in such combinations, physical and digital joins. So basically, they had to model some seesaw, and afterwards, in a physical way, and afterwards trying to represent the same model in a digital way. Most of them used GeoGebra, but not only that. And in that point, I was observing how do they use or how do they transfer these geometrical concepts from 2D to 3D representation. So I did that in last year in Brazil, or 2017, during 5 months. So in the second turn of this experience, one pair of students were modeling this scissors lift, also in both ways, digitally and physically. If we have time in the end, I can show you briefly the animation of that. But then I moved to Canada last year, or 2000, I'm a bit confused right now, 2017 still. The second semester I was there. I was volunteering in a school, elementary school, and secondary school. And then I was doing some workshops with the students, and then I started with some approach in game design. So basically, in the beginning, I was intending to push them in that coding way. So that's the reason I proposed to them this Quarto game. But suddenly they were somehow curious to model this, or they are even more excited in this modeling part, this modeling process. And then in that time, we rented a 3D printer there, and I was so glad to observe how excited they were in get their own models. So I was also doing some activities with 10 years old students, and they were modeling this Blockus game. So in that time, I observed these adaptation and differentiation aspects in doing that. It means adaptation in the way that they were not repeating the same game that they are playing with, but they were doing something different, more personalized, let's say. They were adapting for their interests somehow. And differentiation in the way that it doesn't matter to me or to them how deep they were going, since they were satisfied with that and they were learning math in that way. So I was, as Fabian said before, usually as teachers we are expecting we have all students in the same level, and actually here as much as they were learning something, and I could observe that and also support them in that way, it was okay. So from this experience, I moved to some teachers' experiments in the same way with game design. So we used this game, set game, and still in this adaptation aspect, we were thinking how could we represent this card game in 3D. So we were discussing a bit some possibilities, because since we have to modify a little bit the game, we have to think about the mathematics as well in the combinatorics way, and in the geometrical way as well. Thanks. So this activity we tried out in Israel with some teachers, and also Bea did some experiments in Denmark with teachers. So we were trying to involve them in this modeling process with the perspectives in printing out. So here you can see the models, the 3D printing models I brought here. So if you are interested, you can see afterwards in two different versions. So this is more or less like the original game, but here we have completely different shapes. So when I came back here last year in January, I started to think about these perspectives in combining this 3D printing approach with dynamic geometric system. That was my personal motivation then. And I was thinking the different ways to work with that. So it seems to me the digital, the dynamic geometric system, in one hand, it allows us to explore the dragging mode, but the physical version, it allows us to explore physically and in more playable way. So I was collecting some ideas. So here I have the same experiment that Bea was presenting before, the Viviani's theorem, but in more playable way. So basically is that one. So you can move the pieces and play with that in order to see the triangles in different positions. Also something that Cecilia was doing is with tessellation and tiling. So we were exploring that first in a digital way. So in order to observe this kind of process to get that. And afterwards, we printed out some examples. And Laura del Rio in Argentina is also exploring in a bachelor degree some experiments with calculus and so on. So I'm basically considering different perspectives in different levels of educational level. Also, some other ideas from Canada still, the colleague that I worked with in Canada, she was exploring this bevel spiral, and then I printed out here, and then we were doing some experiments together. And yesterday, Sarah brought this nice example, and I told her it was really inspiring as well. Then I printed out, and I brought for her. But it's an idea really connected with something that I'm doing now in 3D. I'm thinking how many ways we can split a cube, preserving the same area and same volume. And then she told me there was an activity in Israel, and they did similarly with the square, and the student got this nice solution. So I was modeling that in GeoGebra and then printing out. So you can see somewhere here. Yeah, I brought here. If you are interested, you can see later. But the most important to me is thinking in problem solving in real life demand. So we can use this kind of approach to teach them or to prepare them for this kind of creative solution. So here we have two examples. I had a broken lamp, then I printed out this model in order to fix it, And Andreas Linder did similarly with a suitcase, so he was printing out something like that. So it's just to show how we are using, or we can use geometry, in fact, in real life. Also, I have observed in this time, not only with kids, but also with adults in some workshops, different ways to explore it in a creative way. But something that I have observed is how students and users in general are motivated in use their personal connections in doing something with 3D printers. Either they are letters or flags or face, something that are really connected with them. So here we are developing some activities regarding the profile. We have Martin here, if you recognize, is the guy who presented before. And so basically we are taking the profile, rotating it, and getting a vase in 3D. So it's not only for fun, but also to explore which mathematics is behind that. So we can explore the rotation concept, for example. And here we have to develop this spiral in an algebraic way in order to get something like that. So just to finish that, I'd like to share with you my, I would say my inspiration for this approach. Actually, it happened in Canada when we rented a 3D printer there to do these experiments with the students. Before we started with these experiments, we had the 3D printer in the corridor, and a 13-year-old girl passed through the corridor, and she saw a 3D printer there, and she asked, "Whoa, there is a 3D printer in the school. Could I print out my project with this 3D printer?" So we said her, "Yeah, for sure, but we have to manage the time." So we were working with the guys who were in the workshop, and afterwards we printed out for her. And actually she was doing a turbine project to measure the energy. And she was so glad because that there was no way to print it out or to manage that with with something else. And she wrote to Marina, who is my colleague in Canada, and she said exactly like that: "My experiment wouldn't have been possible without it. My project was on how the flow of water affects the electricity generated by a hydroelectric turbine." Yeah. So here she said, "It's amazing. I'm so excited when we gave her this final project." So basically it's that. So if you have any questions, I would be glad to share with you some ideas and perspectives. Thanks so much.